play, and work in this territory. We also want to thank the Ministry of Environment, Conservation and Parks for including us in all the planning it took to develop the new excess soils regulations. And we're pleased to provide our input and expertise and to thank them for asking us to perform this study. As Marianne said, don't hesitate to keep asking us questions and advice. And to the ministry, we're always a willing participant on any research or any work related to the environment, conservation, or parks as it relates to the role of professional engineers. Especially, I want to thank Dr. Made Piranesi and Dave Carnegie, PEng, for all the work they've done on the research and report writing. It really was a remarkable undertaking. For the OSP members, just a reminder, we have our AGM coming up on May 8th, but also for all of you, please check the OSP site for any upcoming events, for our podcasts, Eng Talks, and other exciting webinar opportunities. And with that, I'd like to pass on the proceedings to Dr. Made Piranesi. Thank you all for attending.
All right, thank you so much, Sandro. My name is Made Piranesi. I had the pleasure of working with OSP for the past year almost. And I'm going to start my presentation by sharing my screen. And I hope everyone can see my screen right now. And if you just give me a minute, I will go to presentation mode and start over. So our today's presentation is about beneficial reuse of excess soil at pits and quarries. And my colleague David Carnegie and I will be presenting today's presentation. Here's a summary of what we will be talking about. I'll start by a summary of the project scope and why this project matters. And I will go to the deliverables of the projects, which include a scientific report and a set of best management practices. I will be explaining the scientific report briefly, and Dave will take over the BMP. And you can find both reports on OSP's website at this link. It's actually very easy to find on OSP's website. You could just go to the website and it's on the main menu, but here's the link anyway. So this project wouldn't be possible really without the help of the steering committee that we put together, and it included many professionals from across Ontario. Here you can see their names. I take a minute and read their names in alphabetical order. Amarjit Sandhu, Ashley Zelek, Charles Priddle, Chi Huang, Grant Welsum, Ian McLaurin, Jason Bellingham, Jim Walls, Karan Jandu, Kirsten Grudy, Krista Barfoot, Leslie Rich, Nafisa Burhasani, and Tom Goth. Thank you everyone for your contribution. So this project is important because in Ontario, we know that we are producing something around 25 million cubic meter of soil every year. And this soil, this excess soil used to be sometimes go on waste and used to be dumped in landfills. Starting from 2025, this won't be allowed anymore. And contractors and project leaders, they must think of ways of beneficially reusing these volumes of excess soil. So pits and quarries are a very good destination for this soil to be reused. We have some 5,000 pits and quarries in Ontario that are active at the moment, actually more than 5,000, and some 8,000 inactive pits and quarries that include abundant sites. So the specific objective of this project was to look into the standards of excess soil reuse and to see whether we can snap out of this current definition of inert fill that is based on a famous definition of Table 1, which happens to be very restrictive. And because of this restrictive standard, we didn't have the opportunity to reuse all the excess soil that we generate in Ontario. So our main question was really, can we use the standards that are developed by the MECP to develop a safe and flexible set of standards for rehabilitation of pits and quarries using backfill? And this project is important because if we get to develop this set of flexible standards, we will be able to rehabilitate more pits and quarries. And this means minimizing the safety risk, eliminating aesthetic issues that are out there, and local reuse of soil means less trucks on roads, which is going to translate to less greenhouse gas emission and less contribution to climate change. We know transportation is a very big driver of climate change. And at the same time, with less truck on roads, we'll have less congestion and less road deterioration. Also, it's worth to mention that some of these sites are going to be basically reclaiming the natural state of that land, and many species could be attracted by these rehabilitated sites. So with that, I'll get to speak a minute about the schedule of our work and how we got to do the work during the past year. We started in March 2020. We developed an initial work plan, and we put together the steering committee that you just saw their name. In June, we started our literature review, got to work on the academic literature and work that is done in other jurisdictions out of Ontario. In August, we started working on developing the deliverables, starting with the scientific report. And after finishing the scientific report, we extracted the BMP that was developed in a plain language from the scientific report. And throughout this process, we were interviewing and regularly holding meetings with the committee members, as well as professionals even out of the committee. And all these reports were shared with committee members who are professionals in Ontario, and their feedback was considered and reflected in both reports. So I get to speak about the scientific report now that was developed by me, David, and Lee Weisling. And again, you can find it on OSPI's website. It includes a few main parts. The beginning is a literature review of what is out there about excess soil and excess soil reuse, including the work that is conducted in Ontario and other jurisdictions. Then, based on this literature review, we started analyzing the options that we have for reuse of excess soil in Ontario. And this included studying the conceptual site model for a pit or quarry and comparing it to MECP's model, and deciding what set of standards are the appropriate ones and why is that. We also looked into the fate and transport of metals under the water table, an issue that is common in pits and quarries. And at the end, we tried to also investigate the issues that are not covered by the current regulation, ORIG 40619. And this includes a set of issues, maybe the most important ones maybe are invasive species and microbiological contaminants. So here's a sort of overview of our literature review and the material we looked into. It included works that is done in Ontario, and you know that traditionally, historically, pits and quarries have been regulated by the MNRF, so we had to look at the standards developed by the MECP and what is developed by MNRF as well. And here's a selection of some of the material we studied, among many more. From the MECP, obviously we studied the reg and associated rules and the brownfield standards and the rational documents for developing these, as well as the BMP that was developed by MECP for excess soil, as well as beneficial reuse assessment tool, or the BRAT. For the MNRF, obviously we started with the ARA, Aggregate Resources Act, and there's a protocol previously developed by the MNRF. This predates the brownfield, maybe not the brownfield, but definitely the excess soil regulation. It's known as Aurora Protocol. That was used to extract some elements of work that was previously done to be used in our scientific report and BMP. We also studied the excess soil policy and the application standards. The other works that we looked into were works done by TORC, because they're the ones dealing with the legacy pits and quarries. Canadian Urban Institute, because they're involved with municipalities, and obviously a ton of peer-reviewed literature. Okay. So another part of the literature review included looking into other jurisdictions, and these 5 were among the most important ones we studied: Alberta, British Columbia, Massachusetts, Minnesota, and New Jersey. We studied their excess soil regulation, as well as some BMPs or standards that they have developed for pit and quarry rehabilitation. Again, the detailed jurisdictional overview is available in our scientific report. You can go study it online, but here are the main patterns that we found in our jurisdictional overview. Most jurisdictions had this very conservative standard that was basically applicable to all cases, but in many cases they had a multi-tier kind of framework that was allowing more flexibility, pretty much like what the MECP has developed here in Ontario. And most jurisdictions did recognize the issue of variability in background concentration. In most jurisdictions, the excess soil regulation was more current, meaning that their BMPs for rehabilitation of quarries and pits, they were kind of older. Therefore, we couldn't find any independent conceptual site model for pits and quarries in these jurisdictions. And one of the main differences was that some jurisdictions required pits and quarries to register and to submit a few documents in advance, some information in advance, basically because the amount of soil that they will be importing is usually larger than a typical excess soil setting. So as I said, we couldn't find any independent conceptual site model in these jurisdictions, but the literature that is developed in the mining industry was a little bit helpful, and we tried to look at what people have done and see what are the common elements that we can find and compare it to what the MECP has developed, and see if the conceptual site model developed by the MECP works for a pit or quarry. So I'm sure most of you have seen this figure here. It's developed by MECP and shows the conceptual site model behind the brownfield standard and excess soil standards. So again, we concluded that most of the pathways, most receptors and contaminants, they actually work for pits and quarries. But the main difference probably for a pit or quarry is the presence of a pathway that is not considered by the MECP excess soil standard, and that is where you place soil below the water table. And we showed this here in this figure by this pathway called SSGW2, which stands for saturated soil to groundwater. And this could be going to drinking water or the air or surface water. And at the end, we concluded that because of the uncertainty and stochasticity associated with this pathway, we prescribed table 1 for placing soil below the water table. And there's a discussion around placing soil below the water table and fate of contaminants in this pathway in the scientific report. You could read it there. But all in all, we concluded that the conceptual site model for a pit or quarry has a lot of common elements with what is developed by the MECP, with the caveat that there are a few differences that a QP should be aware of. So one of them, I talked about it, it's the presence of this pathway when you place soil below the water table. The other one is the hydraulic conductivity that is built into the generic model, and that is 3 times to 10 to the power of -5 meter per second. And In many pits and quarries, depending on the type of the site, the hydraulic conductivity could be above this. But again, depending on the site, for example, if it's a recharge site, discharge site, or what. And obviously the type of soil. So the BRAT kind of alludes into it and solve this problem to an extent, because the range of hydraulic conductivity is broader in the BRAT. But there are still sites that could go above this range of hydraulic conductivity, and that is where QPs must be vigilant and be aware of this issue. There's an example of how the BRAT can address this issue, and we actually solved an example of deriving a set of standards with different hydraulic conductivity ranges using the BRAT. And again, that is available in the scientific report as well. Another issue that may be important and QPs must be aware of it is the aquifer recharge rate, which is assumed to be 0.28 meter per year for, again, the generic model. For pits and quarries, we have listed a few studies in the scientific report showing that the range could be good, like above this range. And again, depending on what type of site you are working with, is it a flow-through pit or quarry, or is it a recharge site, or what? And at the end, the role of pH is very important, especially again for leachate and placing soil below the water table. The MECP itself is mentioning these range for superficial soil and below surface soil, 5 to 9 and 5 to 11. These are the range that the model could be valid. So if you are working with a soil out of this range, MECP has prescribed table 1. Also, if you think that the groundwater pH may be more varied, which is sometimes the case, you could think of developing a full-scale risk assessment instead of just using these standards that we have here. So with all that sort of preface that I presented, we devoted a chapter to what set of standards are appropriate for a pit or quarry, depending on what circumstances. And we studied all these different standards, including table 1 or background conditions and MECP soil tables. We focus obviously on the volume independent tables because in most cases, the volume used in a pit or quarry is above 350 meters. And this include table 2.1, 3.1, 4.1, and 5.1, which are known as stratified site condition tables, shallow soil tables, and near surface body tables. We also looked into the feasibility and suitability of using lake fill guidelines or shore infilling standards, and explain why some of these elements could be or may not be appropriate for a pit or quarry. At the end, what we came up with was this flow chart that I believe is pretty convenient to use. And it's basically showing that depending on the, depending on the circumstances that you are working under, you would be deriving different standards. As you can see here, the only circumstance under which table 1 is appropriate is where you are working with environmentally sensitive sites or when you are placing soil below the water table. So that's table 1. If you are near a surface body of water, you should be using table 8.1 and 9.1. If you are in a shallow soil, table 6 and 7.1 are appropriate. For other circumstances that you're placing soil near surface, you should be using table 2.1 and 3.1. And if stratified site conditions are met, you could use the flexibility of table 4.1 and 5.1 and use them for rehabilitation. So this flow chart is going to be what a practitioner QP would be using, along with this illustration of this that we call the layer cake approach. And essentially what it is, it's saying we recognize that a pit or quarry could be using a lot of excess soil. Therefore, we are not limiting the QP or operation or the project leader to one table or two tables. They could be using multiple tables. And for example, here you could see that below the water table, we prescribe table 1. For the immediate 2 meters after the water table 6.1, 7.1. After that, table 4.1 and 5.1, where the stratified site condition are met. And for the surface soil, we could use 2.1 and 3.1, depending on the potability of the groundwater. So therefore, instead of, again, using table 1, or like some municipalities that have done using table 2 in the past, we have a suite of options here, and we could extract from these options. And we have a chapter devoted to the impacts that rehabilitating a pit or quarry and importing large volumes of soil may have that are not considered in the XSO regulation. And this includes the following factors. These are some of the factors. There's a larger list in the scientific report in the BMP, but they include microbiological contaminants. This includes, for example, bacteria, E. coli, and those type of contaminants, invasive species, the impact that we could have to the physical flow of groundwater, noise and dust that could be caused by truck works, erosion of soil, and climate change. So here what I do is I'll say a word or two about climate change, and I'm going to hand over most of the best practices around this to my colleague Dave. He will explain that more. But climate change is an issue that we should be aware of. And again, part of the mandate, not maybe the mandate, the goal of the OREG 40619 was to become more climate positive, to have the opportunity of reducing greenhouse gas emissions. And rehabilitating pits and quarries can provide this opportunity because of the nature of these sites. They are usually close to urban centers, and they can contribute to mitigation of climate change if done properly, if this rehabilitation is done properly. The adaptation side, unlike the mitigation side, it's not necessarily something that we take action about today, but the adaptation, again, according to the IPCC, it's the set of actions that we must take to make ourselves resilient against the impact of climate change or exploit the positive impact of climate change, if any. And this includes planning for the future and being aware of the potential impacts of climate change and how to confront those impacts. For pits and quarries, again, we are talking about Ontario. It's a very broad area geographically speaking, so the impact of climate change could be different. But the generic patterns are as follows. We'll have more precipitation and an increase in temperature, generally speaking. And this means more erosion in pits and quarries because of more precipitation. The change in temperature can change the balance in native and invasive species in different ecosystems. So we might end up having many species migrating to where we live, depending on where in Ontario we live. In northern latitudes, we could have the permafrost melting, and this may affect the operation of pits and quarries in the construction industry in general. And but again, we should know about our local climate and the microclimate of where we live at, and try to adapt accordingly. So with that, I guess I got to finish my presentation in about 20 minutes, and I'm gonna hand over the rest of the presentation to my colleague, David Carnegie, which is about the best management practices for use of excess soil.
Hi, everyone. So hopefully you can see me and hear me. I'll look for any waving hands or Marianne shaking her head if there is an issue. So I'm going to jump in and talk about the BMP document, the best management practices. So the BMP was based on the scientific review document. And again, with the support of the steering committee, whose help was invaluable in pulling this together. And we'll just, there we go. So what is the BMP document? So the intent of the BMP document was to provide more of a summary, plain language overview of some of the key considerations in terms of applying, the excess soil standards to a pit or quarry setting. It's worth noting the excess soil rules. We mentioned groundwater quality here. So when we talk about groundwater quality, it's in terms of how may soil affect groundwater. It's important to note that the excess soil standards don't consider groundwater. They were modeled assuming that there may not be monitoring wells, such as the case with, say, a contaminated site under Reg 15304. So the development of the standards and the rules really guide, there's some key assumptions in there in terms of ensuring that the groundwater remains protected. We also talk about best management practices for site control and how do you evaluate, how you receive soils and how they're provided access to the pit or quarry if that's a decision that you're pursuing. We talk about non-chemical contaminants and other issues to be mindful of, consultation and engagement, and then we'll talk a little bit more about the climate change and how that might impact how we use these soils and what happens to them over time. So I think it's key to point out that the BMPs and the scientific review document, they don't supersede the ARA. For licensed sites, that is the overarching regulation, and in the excess soil regulations, this is the section that speaks to instruments. So, a licensed site with a site plan, that's going to, if it's specifying that you must use a specific quality of soil, or if it's saying that you can't accept soil, that takes precedence. And in that event, if you want to modify your site plan, you're going to have to work with your team and engage with the MNRF and make sure that any changes are made with the support of the MNRF. However, the intent is that these documents might help to create some discussion and decide circumstances where it might be appropriate to clarify the site plan and broaden the types of material that could be reused. The BMP is developed based on Reg 40619, which is the excess soil regulation and the associated rules. So again, when you're reading these documents, I think we can't stress enough that the ministry has developed these regulations and rules on the basis of a conceptual model, and that model has inherent assumptions. So I think it's always good or critical to ensure that you're not invalidating any of those assumptions, i.e. that you're invalidating the model. And we try to highlight those in the rules and the regulations. We try and highlight those things in the scientific review document and the BMP, some of the important ones, but again, it's always good for you to check yourself and just have comfort that you understand why they're there and how they were developed. In developing our BMP, we relied heavily on the previous excess soil best management practice. So this predated the regulations and rules, but it has some very good structure and some good suggestions around some of the factors that aren't discussed in the rules. So some of the invasive species concerns, or some of the the erosion and noise concerns, again, that we'll touch on later in this presentation. We also wanted to flag, we won't spend too much time talking about it today because it's a topic all in its own right. But the BMP recognizes that the BRAT and a full risk assessment are may be appropriate in specific circumstances. So where you think the generic soil standards may not apply, or where you think that there might be site-specific conditions that might allow you to explore some of the the benefits of using something like a broader risk assessment. That remains an option, providing that it's supported by the setting of the pit or quarry. So we talked about that licensed sites, the ARA applies. The site plan will generally speak to quality and quantity. If it doesn't, then I think you need to have a discussion because you don't want to surprise your regulator or your officer by doing something without their awareness. So I think as a best practice, good communication with the Ministry of the Environment and the MNRF is critical because they're the ones that, if there are concerns, they're going to hear about it from the public, and that's never a great position to be in. So I think work with them. They're talk through what you're planning on doing and communicate before you do. With respect to unlicensed sites, so these are sites that aren't under a license. In this case, it's likely the municipal bylaw or a municipality will have say in what happens at these sites through zoning and other tools. So I think you need to be clear on what the bylaws are in the area that the site is set. There might be a fill bylaw, there might be zoning limitations, and Medea touched on the number of sites that would be considered abandoned or unlicensed in Ontario. So again, we recognize that there are people do own these sites, and they may be looking at using the excess soil regulations and rules to use these sites to receive material. And I think, again, we can't underline enough the importance of, again, engaging with your local municipality to ensure that you're doing everything in accordance with their local requirements, as well as engaging with your local ministry officer. So let's talk a little bit about some of the standards for protecting soil and groundwater quality. So I think at any site that's going to be receiving this material, the question should always be, what is the site going to be used for at its end of life? And again, the site plan, if it's a licensed facility, may specify this. Again, if it's an unlicensed site and there's municipal zoning or bylaws, this might point to what the intended or the hoped for use of the area is. So I think you need to be sensitive to this when you're accepting material and ensuring that when you're accepting the material that you're keeping this end use in mind and ensuring that it's what you're doing is consistent with maximizing the reuse of that site and the rehabilitation of that site. We talked about groundwater. Again, you have to decide, is the site in a potable setting? Is there a chance somebody might be using, either, doesn't matter if there's a well beside the site already. It does matter if it's there already because it means that it's for sure used for a potable purpose. But I think the intent is also to think about the future. And if you know that that somebody is going to be developing the surrounding area for residential purposes and they're going to be on wells, then you have to be respectful of that and think about that. The BMP talks about considerations such as surface water receptors, impacts to streams and lakes. We talk about shallow bedrock setting. And again, Mark, I saw your question. We can talk about that at the end of the presentation and talk through that a little bit more. So there's some specific factors that come into play there. I think the key thing is to think about, are there preferential pathways? And again, the rationale documents speak to that. It's really hard to model for certain things, for example, in a karstic environment where you might have, many orders of magnitude difference between, your permeable material and your less permeable material. So as a practitioner, if you are in these settings, I would say, you really need to proceed with caution because the models, they can't envision every situation. So I think you have to really go back to first principles and think about, what am I putting there and what's the risk that it could end up at a sensitive receptor? Because at the end of the day, if you cause harm, then you're accountable for that harm. Medea's touched on environmentally sensitive areas, so that's defined in the regulations and rules. And then I think the last piece is thinking about whether or not you're going to need a record of site condition at the end. And again, the rules and regulations talk and the BMP talk to some of those considerations in terms of ensuring that all of your soil management will allow you to obtain that RSC at the end. So Mitigation showed a framework for how you might work through deciding what soil to place and where to place it. Again, you need to use some professional support here to ensure that you're not invalidating any of the considerations, but we've picked a couple of different settings, and we'll walk you through a couple of different case studies. So Mitigation previously showed this, and we talk about the different generic standards that might apply based on depth, and we'll talk a little bit more. So this is your typical, this might be a pit setting here where these would typically be your sand and gravel deposits. In a lot of cases, these facilities may be entirely above water table, but we also recognize that they can be below the water table. And then there's this other type of setting where it's more of a quarry type setting where you might be placing material directly onto rock or within rock. So we present these two ideas within the BMP. So case study one was shared with us by one of our colleagues on the steering committee. So much thanks to Jim Walls for this. And this is a case where this is a case where we wanted to take a real site and just sort of think through, okay, let's put a picture to some of the concepts or the ideas and the excess soil rules and regulations. So this is a facility that has an approved fill rate of 600 triaxial trucks per day, so 6,000 cubic meters a day, filling of approximately 25 years. So that's what it's going to take to rehabilitate the site to the desired end use. The approved quality is table 2. All filling is above the water table, no surface water bodies adjacent to the site, and they have the controls in place to ensure that the stratified site condition is met. So working through the logic of this site, which is currently table 2, a practitioner could work through this decision-making matrix, and they might be able to arrive at a conclusion that at depth, table 4.1 might be appropriate, and then reserve that table 2.1 standard for that upper 1.5 meters, which again increases the beneficial reuse of materials, or the range of beneficially reused materials, in a manner that's consistent with the CSM and the regulations and rules. So one of the issues that came up was groundwater. And again, because the excess soil standards don't consider groundwater monitoring the same way that Reg 153 does, there's certain provisions in the rules around this, such as leachate testing, and some modeling that was done in terms of deriving the standards. So, the excess soil standards are more sensitive than the contaminated site standards I want to say infinite fills, volume independent situation. So this is where you're accepting more than the, more than the 300 cubic meters that were assumed. So we talked about, in this respect, the rules and the regulations are conservative in terms of protecting groundwater, and that's assumed. And we talk about some of the situations where that may not apply, like where you have to be a bit more cautious. But with that being said, I think practitioners can consider multiple lines of evidence in ensuring that groundwater is protected. And so the ones that we consider in the BMP are, first is the soil standard. So choosing an appropriate soil standard and making sure that you're not invalidating any of the assumptions of those standards. And those again are outlined in a BMP. Your leachate analysis, so that's the MSPLP. And we talk a little bit about fill placed in water. So again, the modified SPLP was developed to model precipitation flowing through a material that was placed, and the how contaminants might partition into that precipitate. So I think that's where we were a little bit cautious around material placed directly in groundwater. If the groundwater has a very aggressive pH, for example, and so those of you in the mining industry would be familiar with highly acidic settings. those types of settings apply, then you probably need to proceed with caution. And I think that's why we are on the side of table 1. I think more research would need to be done to demonstrate that it'd be safe to place material there. And we reference several models that are used in the mining industry to evaluate material and determine whether or not there is potential for leachate formation. And while it's not assumed in the rules and regulations that there will be wells on site, as a best practice, if you do have these wells on site, not a bad idea to have some baseline monitoring to understand where you're starting. And I think the concern with relying on the wells too much is that they're kind of a trailing indicator. By the time you start seeing impacts in groundwater, it's too late. So I think using the groundwater wells to understand where you started and to continue to monitor to make sure there aren't any changes, I think there's value to that, particularly if there's concerns raised. You can have some early warning if there is going to be a problem, but again, the best practice is you don't want to be in that position. I think the best practice would be use the first 2 lines of evidence first in terms of having stringent site controls, using conservative standards for the setting, and making sure that your leachate analysis is appropriate, that you're screening for the right contaminants. And again, if unlicensed sites, there might be municipal bylaws in place that might require additional requirements. So as a condition of filling. So if that's required as a condition, then you're going to need to do it. And again, that's talked about in the rules. Sorry, in the BMP. So in terms of receiving soil reuse, so some best practices are, ensuring that there's been an assessment of past use at the source site, that you've looked at the sampling and analysis plan, and you're confident that the site is well characterized, that they've considered all the potential sources of contamination, that they've tried to identify the worst case scenario, so the worst case concentrations, and that they've detailed that in a soil characterization report. And then the assessment report is, again, this is something that a source site would develop, but it speaks to the types of sites they think might be an appropriate use case for the soils. And so if you're a pit or quarry, you're going to be looking at that document and just making sure that what they're saying in terms of the quality of the soil is or will be is within the appropriate uses and quality for your reuse site, thinking about your specific setting. As a best practice, no material should be accepted at the reuse site without prior agreement. And first step is know what you're going to be receiving, make sure you've reviewed all the documentation and you're comfortable with it. Then the next step would be to enter into a formal agreement. That agreement should make clear who's responsible for what happens when, if there's a questionable load. I think there should be clear communication and reconciling records. So being able to track where did the soil come from on the receiving site end, and for the receiving site to be able to send those records back to the source site to reconcile and say, okay, we know the soil ended up where it was supposed to go. And that, there's good. So for audit control in the future, if there's any question about the source or the quality of the material. And that's through the hauling record. So both sites, the source site and receiving site, ideally will have copies of the audit records, just so that they have comfort that everything was managed properly. And then at the receiving site, I think we provide some recommendations or some best practices around thinking through your quality control and your quality assurance procedures. So yes, that before you accept the material, it will have been sampled. The excess oil rules have good guidance in terms of minimum sampling requirements, in terms of what has to be sampled and how frequently for a specified volume. But a best practice would be to have some checks and balances in place to, again, I think at the receiving site end, thinking through, okay, well, what are the risks? So, am I accepting soil from a site that there's a high degree of potential for heterogeneity? Who is the operator of the source site? Do I trust them? Do I have confidence that it's a well-operated site, well-managed site? Do I have, using your visual lines of evidence and your olfactory lines of evidence at the gate, like before you even allow them to unload the material. If you're finding there's a lot of infractions or there's a lot of non-compliance in terms of just following simple procedures, then that might heighten your awareness about potential for non-compliance, and so you may want to increase your auditing frequency based on that. At the end of the day, it's not a zero risk proposition, so I think you want to think about how you manage your risks and where do the risks lie. The other example might be if you're receiving from multiple sites. So if you're, a more simple receipt scenario might be, you're receiving from only one source site, one operator. But I think as the complexity rises, then your audit procedures and your quality control procedures are going to also increase, just to make sure you're not ending up with something that you don't want at your receiving site. So the MNRF, the existing protocol was that one sample be collected for every 10,000 cubic meters. So again, these are audit samples. This is over and above the initial characterization of the material. The soil rules specify minimum of 3 samples for less than 600 cubic meters or less, and then goes up from there, 1 per 200 cube. With different, again, if you look in the rules, like with different numbers as the volume escalates. So I think, good to rely on those, but again, the 1 in 10,000, I think it's a bare minimum. And again, that protocol assumes that you're receiving table 1 soils, which is a very high quality soil. So I think, again, as you're receiving soils that are, further away from table 1, then I think you want to be considering having a better screening, a really strong screening process and audit process. The other thing that can help with all of this is implementing a tracking grid. So gridding out your site and ensuring that you're reconciling those loads with where it's ultimately placed. So that's your, you might have a cell A1 and you would note, which loads from which source sites went into A1. So that way, if there's ever any question, where to find those soils and you can access them. Again, as a best practice, receiving sites, and again, a lot of pits and quarries may already have these facilities in place, but you're going to want to have signage, fencing, gates, like to control access so you don't have uncontrolled placement of material. Critical that you have somebody responsible, like who's going to have care and control over the site, that's going to, determine who's allowed access and who they're going to be, that they have appropriate training to screen loads and to identify, what are the requirements of the records so that, that they're not just approving soils based on how they're feeling that day, that they're following a well-defined auditable procedure. Loads that haven't been pre-approved should be rejected at the gate. Loads that are accepted, they should be led to the appropriate grid so that, again, everything is reconciled. They shouldn't be allowed to just dump the soil where they please on the site. Other controls are, maintaining your daily records in terms of, what you've received from whom. And again, this is all spelled out in the BMP. So you're tracking truck plates, the number of trucks, the date, any rejected loads. And again, as a best practice, if you're seeing repeated rejected loads from a site, you may want to consider just halting any receipt until you can work out any miscommunications or any issues, or have some confidence that, that they do have good understanding of that source material before you continue to accept it. Again, in the regulations, it talks about the requirements of the project leader to maintain records. So definitely want to familiarize yourself with that. And again, licensed sites may have additional requirements, that are prescribed in the site plan. So you want to make sure that you're complying with all of those as well. So we talked about non-conforming materials briefly. So this is, you get a load that smells off or looks off, or is not from an approved site. Ideally, the non-approved sites aren't given access at all. But in a circumstance where you are encounter with a non-conformant load, or it looks like somebody is trying to place something that shouldn't be placed properly, you probably want to, a best practice would be to communicate with your permit authority. So if you've been permitted by the municipality or the MNRF, they're going to probably require you to track this and communicate this to them, just so that they have situational awareness of what's going on. If there are problem operators or problem sites, again, you're going to, in a worst case scenario, if this material has somehow slipped through and been placed, you're going to use your grid, and you're going to go back and deal with this material. You're going to have a protocol in place for addressing non-conformant material, and keep record of actions taken to deal with it. So your protocol may be that ideally it's rejected at the gate and it never gains access to the site. You may have a process where there's an interim step on site, so where the material is placed at kind of a holding pen pending QA, and if it fails QA, then it's going to a licensed facility. Again, you're going to be maintaining all your QA sampling records. So any screening that was done, screening checklists, any sampling results that you have obtained, you're going to keep all that as part of your records should you get audited, or should there be any concerns. So I'm going to try and move quickly through the last few things. So we talked about the chemical concerns with soil, but there's other issues that can arise when you're moving soil. So one of these concerns are biological contaminants. So again, there's no standard arrived in the excess soil rules and regulations, but it's quite clear in environmental law, like you have to consider adverse impacts. And so if you're accepting material where there, for example, could be potential that it has a bacteriological contaminant, something like E. coli, then you need to consider that, and you need to manage that risk. Or you need to consider, are you going to accept that material in the first place? Maybe it's not appropriate to accept it, based on the settings. So, just because it's not prescribed in the regulations, or there's not a standard prescribed for soil standards, I think you still need to consider it. And so, some common sources we've talked about, for bacterial contaminants could be, from biosolids associated with farming, biosolids associated with the remnants from sewage treatment. If excavation was occurring in the vicinity of sewer pipes or septic tanks, again, you might want to consider the risk of some of these materials having something that, and having bacteriological contaminants or microbiological contaminants, and how are you going to screen for those? And are you in a setting that would pose an unacceptable risk? So, for example, a potable setting, where that could be an issue. We also talk a little bit about invasive species. So again, ideally, if you're moving soils within a local area, this manages the risk. This probably becomes a bigger issue if you're moving across boundaries, so across municipal boundaries or larger distances. But again, I think it's worth considering, if the intended end use of the site is, as future habitat for native species, then you probably don't want to start them off competing with an invasive species. And so you want to be doing a bit of due diligence on the source site, whether or not some of these invasive species are present. If they are, you need to again decide, are you going to accept the material, or are you going to have a screening process to ensure that you're not introducing these materials, and to manage these materials if they do show up. Yeah, and so some of these BMPs, we talked about sampling and avoidance. There are procedures for the Ministry of Agriculture, Food and Rural Affairs has in terms of evaluating for nematodes. Again, if the site's going to be used for agricultural purposes, and if you do notice presence of invasive species, again, there's recommendations to contact the MNRF and work with them to identify A, they probably want to know where that site is, and B, can provide guidance on how best to manage those species if they are present. And we talk also about screening your receiving site just to ensure that these species aren't taking hold. Erosion and dust. So again, a lot of these sites that we're contemplating, so active sites for sure will have procedures in place to manage erosion and dust. So the assumption is this won't be new, and that a lot of the procedures probably are already in place to deal with this. Again, we provide some guidance practices around, considering, weather conditions of the day. If it's really windy, maybe want to limit placement, or you want to have procedures in place to place them in a sheltered area. Again, the anticipation here is that at some of the unlicensed sites, this is going to be a bigger concern where these protocols may not be in place. And again, there's best practices identified in the BMP around how to mitigate some of those concerns. Turbidity and flow. So again, we're talking here about erosion. Also, again, if you're in a highly permeable environment, again, just groundwater turbidity, and like, is there a potential that you could have impacts? If, again, being really sensitive to if there's wells in the vicinity, again, you probably want to be really cautious about, if at all, receiving material where that could be a concern. And again, part of the BMP talks about if these are active sites, that during extraction, that would be your first warning sign. So if there were turbidity issues during extraction, then you're probably at a high risk of having turbidity concerns during reclamation, and you might want to think really hard about that. Not a hard and fast rule, but again, a line of evidence that somebody could consider. And then again, we talk about some ideas around managing turbidity issues, using a more granular free draining material, in the water table, or having, things like silt curtains or erosion control measures in place to, again, limit the potential for turbidity formation. Noise and vibration concerns, again, active sites would have these procedures in place already. BMP speaks to, when you're placing material, generally there's going to be less noise and vibration than, say, an active quarry where there might be blasting, or so again, it's not anticipated to be a big issue, but it's something to be aware of. And again, for an unlicensed site that's maybe not been used for extraction in many years, the surrounding community's probably gotten used to that site, or become used to that site being relatively quiet. So here's where the communications plan will be critical. And again, we talk about things like managing hours of operation, procedures in terms of your operators, placing material in a way, or moving material in a way that's mindful of the surrounding receptors for noise, and mitigating those where possible. Again, the community engagement and consultation piece, particularly important for the legacy sites, so the sites that are no longer licensed, where there may not have been any active extraction. And some best practices are listed in the rules. So you're going to want to engage with the local, probably municipality. Probably going to want to engage with the ministry. Probably may want to have some town halls or some efforts to advise the public of what you're proposing to do, and ideally to identify any concerns or issues up front. So being aware of, are there sensitive receptors nearby, being aware of, are there certain sensitivities around certain hours of operation, or noise concerns, and how are you going to receive those concerns and address them? Because again, we're trusting that everyone's going to want to have a well-managed and well-operated site. Be sensitive to these concerns. So we're coming into the last slide. The last thought is around climate change mitigation. So, it's mentioned several times in several different documents, but the real best practice around excess soils is to limit their generation in the first place. So wherever possible, reuse at the source site, or limit the generation of excess soils through design and planning. Recognizing that's not always possible, but that is the best practice to try and reduce the amount that's produced in the first place. Again, the most climate positive reuse is not trucking it, is to keep it at the source site. The next best option is to have it travel the least amount of distance. Ideally consider routes or times that limit idling, or slower transport, and think about your operational efficiency of the on-site. So reducing idle time, and choosing equipment that is more climate positive, if that makes sense. And then the rules, the BMP talks a bit about some of those considerations as well. Miday touched briefly on, I think the other thing that's going to be challenging for a lot of receivers is just thinking about what the future might hold for your area. And again, I think this continues to be emerging science, but when you're placing material, don't think about where the water table is today, for example. Think about, okay, what is it going to do in the future? And ensuring that when you're placing material, you're placing it in a manner that has an element of resiliency, so that you're not pushing the boundaries of what's acceptable today. You're building in a little bit of conservatism, with the expectation, okay, well, what happens if my water table comes up a meter? What happens if I have an extreme rain event? How am I managing those concerns to limit the potential for impacts? So with that, I'm going to stop talking, and Marianne's going to handle questions. And Miday and I will jump in and answer them as best we can. If you have questions, you can use the raise hand tool within Zoom, which I think a lot of you probably already are well pros at by now. But if not, no worries. There's also a chat box, and you can input your questions there. And with that, I'll turn it over to Marianne.
Great, thanks, Dave. We have some questions in the chat box, which I will read out in order as they were received. So Miday and Dave can just jump in and answer. The first question is from Mark. I see that Mark has actually left, but we are recording this, so he'll still have the answer in the recording. So the first question from Mark is, in the north, bedrock is encountered above the water table. What table would you use?
Okay, I'm gonna have a stab at this question to give Dave the opportunity to recharge a little bit. And I think when, not only in this situation, every other situation that we work with pits and quarries, we should go back again to the first principle, see how does the MECP standards apply to our work. So here we are dealing with a shallow soil. The bedrock is pretty shallow, and I think if the water table is below, what we should do is, what happens is we are placing soil to the rock. So there's a possibility of presence of preferential pathways like fractures and so on in the rock. So I think using 6.1 and 7.1 would be the most appropriate, because what happens is MECP in their full depth setting, they assume that there is a layer of soil with a minimum depth of some 3 meters. So what happens, I think, in this situation, we should start with 6.1, 7.1, as long as we are above the water table. And then after 2 meters of these soil, placing the soil, we could go back to 4.1, 5.1 if stratified site condition is met. And if we are hitting the surface already, we would go back to 2.1 and 3.1. Hope that was clear. Anything to add, Dave?
Okay, thanks, Miday. There's a second question from Mark. He's asked, was acid generating rock situations addressed by this guideline?
Mm-hmm. I think the MECP about the soil matrix, it's clear about the range of acidity that the guidelines are going to be valid. We generally assume that, I mean, at the back of my head, I usually assume that pits and quarries are usually more basic rather than acidic, but there are, I think I mentioned this in the scientific report, that there are situations that rocks could be acidic. For example, pyrite and those minerals could generate acid, I think. I think the safest thing would be, again, going back to the assumptions. And if you think that you will be out of that range of acidity, going back to table 1 is the most appropriate option. If you think table 1 is not appropriate, we have a set of different computer programs and modeling tools in the appendix. You could visit those as well. And that's my 2 cents on that. David, what do you think?
Yeah, I think when in doubt, like if you know you're in acidic concentrations, then probably it's worth doing that gut check again, because the excess soil standards, it models, again, the pH range is for soil, so the pH of the soil, and really the pathway for that soil to leach, most of the assumptions is around it's going to be through rain, like through precipitation. So again, if you're putting that material in a very a very acidic or a very alkaline solution, I think that's where we had some uncertainty around it just really depends on what are the contaminants that are in place, and it's mostly the metals that are going to be the primary concern here, because they can speciate in different ways. So it can affect their mobility, and it can affect their toxicity, and there's general rules around range, like which contaminants can be expected to be more of a concern based on a more acidic versus more alkaline situation. But the bottom line is we don't know, and so I think when you are finding yourself in those situations where the model doesn't address that or can't answer that, that's where you're being forced into more of a risk assessment. And then through that risk assessment, you can look at other science or other lines of evidence, such as some of these tools that are used, for example, in mining, in terms of how they model for formation of different contaminants.
Great, thank you, Dave. The next question is from Jay Flanagan. If the ARA pit license has a note that requires clean inert fill be used for rehabilitation, what table would you use?
Sorry, I was on mute. I think this was pointed out in the presentation. Dave mentioned it as well, that ARA takes precedence. So I think if one possible way, again, this is something between the licensee and ARA at the end of the day, and this requires approval from the ARA. But one possible solution that came out during our meetings with the committee members was the possibility of adding a note to your site plan, and people have done this in areas that they have elevated backgrounds and so on and other conditions. Adding a note to your site plan saying that we will be doing this modification, and upon the approval from the MNRF, I think you could possibly refer to this set of BMPs that we have developed and take advantage of this piece of work. And which table specifically? I think, again, it depends on site-specific situation.
Yeah, but I think part of that question too, I think some of the existing protocols define, so the existing MNRF protocols define inert fill as table 1, I think is the unstated conclusion. So again, if it was defined, if your site plan was developed you referencing that protocol or relying on that protocol, then that's the definition. So I think in terms of what Medea is saying, that's would be the interpretation, unless there's some modification of the site plan through clarification with the ministry. Great,
thank you. Next question in the chat box is from Melanie. She asks, MNRF seems to be discouraging importation of fill unless it is specifically required for rehabilitation. There is a concern at MNRF, in my experience, about regulating a site where extraction is completed and has shifted to a commercial fill operation. Has the BMP considered encouraging MNRF to be more open to beneficial reuse of soils as an environmentally responsible practice?
I think obviously I cannot speak on behalf of MNRF, but one thing I can tell you is that MNRF has a delegate in the steering committee, and they are completely aware of this effort, and they have some level of cooperation with MECP and the possible cooperation with the MECP using the best practices and standards developed by the MECP. But I think this would, again, go back to the strategic view of MNRF and how they want to manage the situation. But my personal opinion is that the point of this project and the way we are approaching this thing in the industry in general is to be able to reuse, repurpose the material that we have in construction industry and get a sort of win-win-win situation out of this thing as much as possible. But I think the question is really directed at the MNRF rather than Dave and I.
Great, thanks, Made. The next question is from, sorry. Hold on a second. Sorry, I just lost my box. It's from Jay Parkin. This is all very interesting. My question is, what is the MNRF's position on importing fill for rehabilitation, or your understanding of their position? They have the final say.
I think this is very similar to the previous question. I repeat that MNRF had people in the steering committee. We got to talk to them. We benefited from their inputs, but what their formal position is, I cannot speak to that at this moment.
Yeah, I think the only thing I'd add to this discussion is, again, implied in the work we've done is that the best practices of excess oil reuse apply, and so pits and quarries aren't intended to be, they're not intended to be a dumping site for this material without a beneficial use, right? So if I think this case still has to be made as part of the pit or quarries rehabilitation plan, that it is in the best interest of that site as part of its rehabilitation, that filling is supported by that. So it has to be part of a bigger picture, a bigger strategy around, okay, what is the purpose for accepting the material? It can't be just as a, just to, fill the hole for no reason. I think there has to be some understanding, okay, well, we're filling it because it's going to be used for this purpose at the end of the day. And this is how filling supports that beneficial reuse. So returning it to a higher and better use. There may be situations where leaving it as a hole in the ground, maybe that is the best and highest use for it. But it's going to be very setting specific and considering why, like what is it for, to what end.
Great, thank you. Next question is from Joe. He asks, are mining open pits also included in this regulation, or are there similar efforts to handle their excess soil?
If you're referring to our BMPN scientific report, the answer is no, it's not a part of the scope officially, but the science and when I looked at the literature, many elements were common for an open pit, whether it's a mining industry or it's an aggregate pit. Many elements are common, but there are definitely differences, including the high concentration of certain metals in mining industry. So officially, no, I don't think we had any intention of covering this category, but there are common elements.
Great, thanks, Made. Next question is from David. He asks, can you outline the first steps in getting a site approved for receiving excess soil?
David, do you want to tackle this one? What are the steps for receiving excess soil?
Yeah, so again, we'll assume that we're talking about so the first question, I think, is in the context of a pit or quarry, is it a licensed site? So is it under the jurisdiction of the MNRF, or is it a site where the license has been surrendered, or it's abandoned? So because that's going to speak to jurisdiction. So if it's a licensed site, you're going to be dealing with the MNRF. So the first question is, what does the site plan say? So does the site plan contemplate rehabilitation with fill, or does it contemplate leaving it as an open, that it'll just fill with water and be left as a pond? So I think that's the first question. If it already contemplates receiving material, so backfill is a component of its rehabilitation, then I think the second question is, okay, so what is the existing standard? And again, it may or may not speak to that standard. And so you're going to have a discussion with the MNRF about modifying the site plan. If you're going to try and introduce something other than inert material or table 1, which is what a lot of the site plans have defaulted to. If it specifies table 2, then I think you're starting to get into other some of the other Reg 153 tables. So I think there's might be a basis there to talk to the MNRF and walk through, okay, says table 2, looking at these new excess soil rules and regulations, here's some new standards and here's how they might apply to the setting. But you're going to have to walk through, again, going back to those first principles and considering what is the site setting, what is the concern. So we're aware of pits and quarries that might be located in an urban boundary that's serviced. I can think of a couple, where I live. So, there the concerns are, there's not a potable groundwater concern. And so you might be able to have, a different type of conversation with the regulator than a setting where, there's, farms adjacent to it or, a residential community adjacent to it. But yeah, so if it's licensed, bottom line is you're going to have to work through a site plan amendment, and that's going to be done, with through the MNRF. And as part of that amendment, I think they're going to want to understand, how are you using the material beneficially? How are you going to manage the material? How are you going to ensure that it's safe? And again, I can't speak for the MNRF, but I think these are the things you need to be thinking about: is how am I going to manage risk? Because at the end of the day, the MNRF and the MECP's responsibility is to protect the public. So they're going to want to have a good understanding of how you're going to work with them to ensure that the public interest is protected.
Great, thanks, Dave. So David did say it was a licensed pit, so
yeah,
that's great. So just before we get to our last question, just wanted to send a reminder to everyone that if you have any other questions that come to mind, please drop them in the chat. I don't see any hands raised, but certainly someone is welcome to ask the question verbally to Dave and Made. So we'll get to our last question for now from Carol. She's asking, is anyone or any organization looking into creating a BMP for receipt of hydrovac soils or not dry soils at licensed P&Q?
I guess for this specific project, we, given the amount of time and resources and everything that we had, we didn't make this an official part of the project scope. And my understanding is that this is a very limited fraction of the market. I personally am not aware of any effort at the moment, but I'm pretty sure that the soil rules, if you go to section 3, they have recommendations about liquid soil. They have limits on the amount that you could bring in, how to dewater them, and so on and so forth. But any particular effort that I can think of, it doesn't come to my mind at the moment. Maybe David would be aware of something.
Not that I'm aware of. I know, again, it's the short answer is not that I'm aware of, but again, you'd want to go back to first principles as well, like in terms of thinking through, okay, what are the, if you're going to be accepting this material in an environment that has a lot of preferential pathways, like a fractured rock setting, like probably not the safest setting to be managing those materials. So I think you really need to be thinking about, okay, if you're going to accept this material, why? How is it being beneficially reused? Like, what's the end use of the material, and is it supported? And then how are you managing, concerns to the receptors? And again, depending on if it's a licensed or unlicensed facility, there's going to be different requirements either through the MNRF or through the potentially municipal bylaws on it. And yeah, I saw the note. So Jim Walls, who was on our committee, you might want to reach out to him, because Frisia has noted in the notes that USM has worked through accepting liquid soils with the municipality. So that's a site Jim knows well. So I'm sure he'd be happy to chat offline about that. I'm assuming he's a very friendly guy, so I'm assuming he'll probably he'd be happy to have that conversation.
Okay, great. Those are all the questions we have right now. So I guess if anyone wants to drop in a final question, we're just about 6 minutes before we end, but certainly if anyone else has questions they want to ask verbally, feel free. I think we, thank you, Grant. Well, I think this is the end of our webinar. Thank you, Dave and Madej, for a very informative webinar, definitely by the questions and a lot of people sticking around to the end. It was very beneficial. Thank you to all our attendees as well for attending today and participating. And just a quick reminder, we will be sending out a link to the video recording of this session, as well as to the PowerPoint presentation. So you'll receive an email at the very probably sometime this week with the link to the presentation and this video recording. And thanks again to everyone for attending.
Yeah, Marianne, I just also want to thank Madej for all the great work, as well as Dave, but this ends our current engagement with Madej on this project, but I'm sure we have his contact information, and as we continue to look at opportunities with excess soils and other research, we'll be reaching out to you. So thank you very much today, and thank you, Dave, and everyone else for participating today. Just wanted to make some final remarks.
Thank you. Have a good day.
Thank you, everyone. Have a good day.